Hi everyone. So today we are going to start a new topic on SQL. So you go to Module 5, and under the Learn tab, you can find the SQL Server installation guide, which I briefly explained today, and you can find the slides also here. Okay. Now, as you know, I already mentioned that in class before, but just to remind you, I'm open to any tools that you would like to use for SQL. If you would like to use, for example, if you're more comfortable with open source tools like, for example, MySQL, that's fine. If you're using SQLite, that's fine. I'm using SQL Server. Like in the past semesters, I was always using SQL Server on Azure portal. And that's because my laptop was out of space, and I preferred to use a cloud service. So I provided explanation for both. Like if you want to install SQL Server locally on your computer, or if you don't have enough space or for any other reason, you would prefer to use a cloud services such as Microsoft Azure, or Amazon has services, Google has. So there are several services. I just didn't have time to explain everything in the file, but I provided a few options for you for like any path that you choose. So if you want to, for example, I know some of you have Windows, some of you are using Mac, and so here is the guideline for Windows users if you want to download SQL Server and if you have Windows. And just one thing I would like to mention is there are several things here, like the installation, I mean. First, we need a SQL Server, right? And now this SQL Server can be installed on your laptop or could be somewhere on the cloud. So that's one thing. The other thing is you want like an interface or tool, right, to work with your databases. So we create our databases on the SQL Server, and then we need something like, for example, Microsoft SQL Server Management Studio, right? Which is, I think, only you can only use it if you have Windows. There are ways if you have Mac and you want to stick to Microsoft SQL Server Management Studio. Like, for example, you can use VirtualBox or like other things, but there are also other options for Mac users, such as Azure Data Studio. That is what I was using in the past semester, like the last one semester, not two. So if you want, you can use Azure Data Studio, but the bad news is I just realized that it is going to retire in February 2026. So it's enough for this semester if you want to work with it. But I think a better option, and I'm going to start it, I mean, I myself want to start using it just this semester. I've used Visual Studio Code like before for other programmings, but for SQL, it seems that now, if you see here in the Microsoft website, so it clearly explains, I can provide the link for you too, that is what is happening to Azure Data Studio, and that you can, so the installation document that I provided for you explain how to, for example, install SQL Server. That remains the same, right? But for like a tool that, like such an interface that you want to use with that, I explained Azure Data Studio. So as I said, if it is only for you for this semester, you can still use it. If not, and you want something that is more practical for future, I would highly recommend using Visual Studio Code, right? You probably used it before, maybe for Java, other programming, Python, or any other courses that you had. But you can go here if you install Visual Studio Code. How many of you have already used it before or have it installed on your computer? Okay, so after you install it, you go to, there is an extension for MySQL. So I already installed, added this extension, but if you don't have it, just type MSSQL, okay? And then it provides you several options. The first one with like millions of downloads is the one that you want, okay? So please add that extension. I'll show you, for example, how to create tables and so on in that. So we'll reach there. So I just want to let you know that you have several options. You can either use, first of all, for SQL Server. Okay, so this is the SQL Server part. So for this part, you have the option to install locally on your computer, or you can just use a cloud service, such as, for example, Azure. Like Google and Amazon and so on should have the same. I'll explain this one in this class, okay? And in your installation guide, you also have the guideline how to install it locally on your computer, whether you have like Windows, Mac, and so on. And then so this is where our databases are. And then we need something like Microsoft, for example, SQL Server Management Studio. We call it SSMS. So this is only for Windows. Okay, and it has a lot of great features, but if you have Mac, I would suggest you using like other tools such as Azure Data Studio. Or better, use Visual Studio. Right? And the good thing for this one is that you can use it whether you have Windows or Mac or whatever. And this one is also for Mac and Windows, but will retire on February 26th, okay? So just have to keep that in mind. And in the second half of class today, I'm going to explain you how to, in case you want to use a cloud service for creating your databases, like me, I would explain how you have to create an account on Azure portal, which is here. Okay. And I clearly explained that in your guideline, if you read it, I explained that how you can create a new resource where you put your databases in that, okay? And then from any tools that you're using, like whether it's SSMS, whether it's Azure, whether it's Visual Studio, you can always connect to your servers here, right? So for example, if I'm using this Visual Studio, I can still like connect to my database, right? I only need, for example, my server name, right? And the authentication type, which is SQL login, username and password. And this username and password is what you actually create there, right? So you have to first create your account in Azure portal. After you created an account and signed up, and I would recommend you using your student account, your student email, and it's because I think for students, it gives like some free advantages. And what else? So just back to this file. So yeah, and this is another option, for example, for Mac users, if you, for example, wanted to install SQL Server, and you have to use the developer version, okay? Developer edition. And for example, one option is using Docker, right? You have to set up SQL Server using Docker, so I explained here how to do that. And if you had any problem in your installation, any error or something, you can always ask either the TA or myself during the office hours, okay? And using Azure Data Studio for cloud or local SQL Server, this is actually what I was using, and I'm going to explain it. And and the third option is just use a virtual machine if you, for example, want to stick to something like SSMS, then you have this option, and you have a Mac. Okay, and this is the explanation for using cloud services, no installation on your laptop if you don't have a space, for example. So this is what we will explain. We have to sign up for Azure free account. So you have to be careful here. There are several options in the portals. So for example, I'm not a student, but I was able to use a free account. And when you're going to create a new resource, it shows some amounts in dollars and so on. And I'm going to explain how you get rid of that, okay? I also provided clear explanations here. So this is where you actually, these are the links to create Azure free account if you don't want to use your student account, or sign up at Azure for students, okay? And what they, like the package that they offer, free for students or in their free account, is more than enough for this class, okay? And so you just click start free and sign in with your Microsoft account. Don't worry, I'm going to explain this. If we have time, I just want to review week 5 material first, like go through the slides together. And then at the end of this session, if we have time, I'm going to help you to create your account and do everything here. So you just click, for example, start free so that you can get the free account. And then this is a note. If using Azure for Students, which probably you use, it offers $100 in free credits. So that means someone who is not a student should pay like $100, right, for what you get for free. And no credit card information is required. Because I'm not a student and I don't have a student account, when I'm going to explain you in class, like showing like a demo to you, you will see that I see some dollar amounts, something like that. That's because just I didn't have a student account, okay? And for you, it doesn't have to ask you for credit card information. Even if it asks, which happened, for example, for me, it doesn't charge anything from your account. And I've used it for at least 1 year, and I can promise you it doesn't, if you follow my instructions, it doesn't deduct any amount on your, from your account. And some of the students also used it before, so it's safe. And this is how to create a new SQL database. So once you created your account in Azure, and then you see, for example, I logged in using my York email here. Then, for example, you click on create a new resource, right? And then here, there are many options here, but we are interested in the SQL database, right? You can also search anything that you want here, and you can find it, right? So we only want the SQL database one. And so let's say I click create, and these are the settings. For example, I explained in your installation guide what you have to provide in each, for example, box. You have to, for the subscription, you have to select free trial, right? And so these are just some screenshots. Once you filled out like all the boxes and wanted to create, you see like this box on the right, which shows some amount. The only thing that you have to be very careful is that this amount should be 0. Okay, so this is the amount that is going to be charged, and this should be 0. And then allowing your IP addresses and everything. So I'm going to explain all this. And finally, connecting to your database using SQL client. Now, whether either you're using, for example, Azure Data Studio or whatever that you're using. For example, if I'm going to use Azure Data Studio, it's easy, and I'm going to connect to my database, right? Assuming that we have already created our SQL databases on Azure portal, okay? Now, just click on create a connection, right? And then here, I need my server. So how can I find this? You go to your portal. And here, when you select your database, you can find your server name, right? That is what you need. You just can copy it. Whatever tool that you're using, you just provide your server name here with your, of course, authentication type should be SQL login, and then username and password. For example, my username is testadmin, and some password, and then at the end you have to trust server certificate. This should be true, okay? And then you connect. And here, it just asks for either you have to, for example, if you're connecting from different places, then you have to add your IP address. So you click OK. If it doesn't allow, like this, login failed, for example, for this, it means that you have to add your IP address here. So you go to your SQL Server, right? And where is the networks? Here. Okay, networking. Okay. In the networking, show networking setting, if you click this, you can find here like all the IP addresses that I've added before, right? So you just have to make sure that this is selected networks, and then you just add your client IP address, okay? So I just click on this. So this IP address will be added here, and then I make sure that this is checked, and then click Save, and that's it. So if I go and do this from the beginning, this should work now. So what I want to show you is just that so I'm connected, right? So if you have seen that error that happened to me, don't panic. It just means that you have to add your IP address there. And you can easily go to the network setting, right? Click on add your IP address, check the checkbox that I mentioned, and then click Save. Go back here, connect from the beginning, and then you are here in Azure Data Studio, where here you can see, for example, your connections. If you click here, you can see all the databases that I've created before. For example, this is for 3421 course, right? And then if you click this, it may take some time. It then shows you all the tables that you've created in this database, right? You can create multiple databases, and so I have this one here. Okay, it may take some time, but then it will load the tables here. And the same is if you want to use like SSMS. I don't have Windows OS to show you here, but should be the same. For example, even in Visual Studio, right? You see, it's just a different interface, but everything is the same. So you still have to provide your server name, right? The authentication type, username, and password, and everything is very similar to Azure Data Studio that I explained. So you provide the same information here, you connect to your database, and everything looks exactly the same. Okay, so is this kind of clear for you? I don't want you to know how to like set up everything now, but I just would like you to know by now what are the options you have. You have the options to install SQL Server on your computer or use it on the cloud. If you are using a cloud service like Azure, then you can like do what I'm going to explain in this class to create an account on Azure portal, create your databases there and everything, and then get rid of like all the spaces that it needs to consume on your computer, right? And then it's easy, you can connect from anywhere to your servers. And then for the tool that you want to connect to your server, you can use anything, right? You can use like SSMS, you can use Azure Data Studio, you can use Visual Studio, and so on. And do you have any questions? No question? Is this clear? Kind of? Okay. So how many of you have already have SQL installed on your computers? Okay, great. So you all work with SQL Server, right? And so how many of you would like to install it locally on your computer? Okay. How many of you would like to use a cloud services? And some of you don't want to do anything. So I ask this question because I'm going to explain it in class if I see a majority of you would like to use a cloud service. Otherwise, I don't want to like spend the class time on that, okay? So just asking my question once more. How many of you would like to use a cloud services like Azure? That if yes, I'm going to explain it in class. Okay, so if you have time, I'm going to explain it. Okay, so far, just a quick wrap up of what we have done so far. Okay, so we started with introduction to like relational databases and why we use them, and we had the ER modeling part, right? So for this part, we have explained different entities, right? Different types of attributes, relationships, cardinalities, different types of relationships, and so on, right? And so, what are the different types of entities that we have? Yeah, regular entity, just like any like regular standard entity that we often use. For example, to show the student, products, different objects that we want to keep track of in our database, right? So that will be your regular entities. And now sometimes our entities are, for example, weak entities or associative entities. So who remembers that? Associative entities? Yeah?
It's like you're linking many to many, so you have to use an associative entity.
Yeah, so whenever we have many-to-many relationship, so associative entity is not something like when you look at your problem, you know that, okay, now I have an associative entity. No, it's not like that. So you look at, for example, a student registration problem, you want to create a database for that, and then you have to think of what objects you would like to store data about, right? For example, we would like to keep track of student information, professor's information, classes information, and so on. So these are our main entities. That is what entities mean, right? A person, a thing, a place, or anything that you would like to store some information about that in your database. So that is an entity, and they are mostly like regular, strong entities. Sometimes they, for example, when we design our database, we see that, okay, we have a student and course which have many-to-many relationship, and we already explained why we cannot, why relational databases cannot handle that, right? We couldn't design our tables like with many-to-many relationship, right? Because, for example, we had the problem of where to put the foreign keys then, right? What do you use to connect tables? How do you connect tables in relational databases? Foreign keys, right? So the problem with many-to-many relationship is, like, for example, as I said, we say for each student can enroll in, for example, many courses, right? So if this is your student table, and this is your student ID, a student name, so let's say this is, so this student take many courses, right? And so you cannot just simply add course ID here, right? Because then it's against the properties of relational databases, against the atomicity of the databases, right? We cannot store multiple values here. So that's one problem. And again, if this is a course table, so this is not, we cannot do it because if it is course, for example, database, AI, and so on, we cannot store it this way. Or if we have a course table, like for example with course ID, let's say this is a data course code 3421, course name is database, right? Now we say, okay, let's add the students here as a foreign key. Again, we cannot, right? Because again, for each course, we have many students enrolled in this course, and then we cannot put like 150 students in one cell. So this is the problem with many-to-many relationship, where we introduce an intermediary table to handle that many-to-many relationship, because we want to break down that MN relationship into two one-to-many. Okay? So it breaks down a many-to-many relationship into two one-to-many relationships, right? How? Adding an enrollment table. This is an enrollment. Now, instead of having two tables with many-to-many, now we have three tables, and this intermediary table have one-to-many relationship with both of them, right? So we have enrollment here with a student ID, course ID, and maybe grade or whatever. So now we have, for example, student ID 1, 3, 4, 2, 1. A student ID 1, another course. Does it matter the student ID is repeated here? No, because it's not a primary key here. And the same is for course ID. So for the same course, you see, for the same course, we may have different students, right? And so this table have one-to-many relationship with the course, and also one-to-many relationship with the student, right? Because now each student can have like many enrollments, right? You may enroll in database, you may enroll in AI, you may enroll in like other courses, and each enrollment is only related to one student. What is each enrollment? That is like every instance in your table, right? So you have to look at that. So for example, if this is an enrollment table, each row is an instance of enrollment, right? Same as a student table. If you have a student table, each row is an instance of a student, right? A student 1, student 2, 3, and so on. If it is a course table, each row is an instance of a course, right? Like database, AI, and so on. So here we have for each course, each student, we have multiple enrollments, but the opposite is one, right? For each enrollment is only for one student. Same is for course. For each course, we can have many enrollments because many students can enroll in that course, but each of these enrollments, that is each row in our enrollment table, belongs to only one course and belongs to only one student. So that is how associative entities, which are intermediary tables between like these many-to-many tables, break down that many-to-many relationship into two one-to-many relationship, right? Now, so this is mostly like what we've covered about the entities and different types, and then we talked about weak entities, which do not have their own primary key, but that is not enough to identify a weak entity. So weak entity is also about the existence, right? So you have to think of them as an entity or object that is not strong enough right? It's not strong enough to have its own identity. So for example, when we were talking about course sections, if in a database, those sections do not have, like sections alone do not have any meaning and could be used for different courses, similar to what we have at York University, then that is an example of a weak entity, right? Because we have, for example, section M, section N, section A, B, C, right? But are they unique? No, they can be used for many courses. You can have, for example, database section M. You can also have AI section M, right? So M alone, that is your section number, is not a primary key, right? But together with the course code, it can be a primary key. When you say 3421 section M, then that section M has a meaning. Or when you say 3401 section M, then that gives it a meaning. So they are not strong enough to have their own identity. And they depend on another entity or their parent entity for their existence, like what I mentioned. Or for example, if you think of like HR system, where when you have like some dependents, and then the dependents in your database could be modeled as a weak entity, right? Because they do not have, like, for example, employee ID. And what about the attributes? We had also different types of attributes, right? What were they? Anyone else? Yeah?
There's a derived attribute.
Derived attribute?
Multi-value.
Multi-value? Unique? So unique attributes, unique identifiers, which will be your primary key later, right? Multi-valued means that they can have more than one value, right? And derived attribute, anyone remembers that? Yeah, you calculate that based on a value in another attribute, right? For example, age derived from date of birth. And so what else? And then we talked about different types of relationships and cardinalities, right? We have one-to-one, one-to-many, many-to-many relationship. We talked about primary keys, foreign keys, right? And so by now, you should be able to first define your requirements. If I ask you to design a database so far, you should be, for any businesses, like, it's not only Flower Shop that was in your assignment, but any similar business, you should be able to think about and come up with set of like main entities. What is their relationship? What different attributes you would like to have in your tables later? What would be the columns of? So it's not like you think vaguely, okay, let's add this table, this table. So you now have like a structured mindset about how to design your database, right? So that's clear. And then you know also how to convert that into relational schema. You know that, for example, each entity will be your table later. Each attribute will be your column of a table. Unique identifiers here in your ER model, unique identifiers will become your primary keys. The connection between entities, for example, if you have a student here and enrollment here and course here, right? And so these are connected, right? So they have a relationship. And so you can think about what how your database can look like, right? So you know that, for example, if this is your model, you know that you will have 3 tables, right? And then each table has, depending how many attributes it has, it will have the columns. And then if, for example, here a student ID is your unique identifier, means that your primary key later is, for example, a student ID. Now, if you're connecting a student to enrollment table, when today I'm going to explain how to write SQL queries to create tables. So, for example, you write create table. Let's say a student, okay? And then you just write all the column names, like for example, a student ID, name, and so on, okay? And you define, for example, what is the type. For example, the student ID is, I don't know, integer or so on. And so because the student ID was a unique identifier here, you know that you have to define it as primary key here, right? And if, for example, there was a relationship between two tables, for example, a student and enrollment, and it's a one-to-many relationship, right? And we said foreign keys should be added to which side? We use foreign keys to define the relationship. So later when we want to create these tables, we have to somehow tell SQL how we want to connect the tables, right? How? With foreign keys, right? So we have to also identify foreign keys here. So this is a one-to-many relationship where the foreign key goes, many side, right? So you add the foreign key to the enrollment table. Same as you see here, right? So this is a foreign key. This is also a foreign key, right? Both the student ID and course ID alone, they are foreign keys. Now, so do I need to add any foreign keys in definition of the table creation here for a student? No. But later, if I'm going to create the enrollment table, right? If I'm going to create the enrollment table, then I need to provide the foreign keys here, and I'm going to explain how you, for example, reference, reference to the student, and then also reference to the course tables to define a foreign key, okay? So let's start today's session. Or, let me see, what time is it? Maybe not the start yet. Now that I made a review, of the class so far, let's see who actually listened to me. And then have a Kahoot game, right? So let's do a Kahoot quiz together first. So we have almost 30 minutes. And I'm going to quickly explain introduction to SQL and DDL, or data definition language, which we discussed today. And I would like to ask you to read the installation guide that I provided on eClass carefully. And sorry, Chris. I don't think so. So most probably your midterm will cover everything before SQL. Okay?
And is it MCQs as well, like questions and MCQs?
Yeah, it will consist of multiple choice questions, true, false questions, and also problem solving. So one or two. So your midterm exam is on July 2, and the same time as our class. And so it will probably cover everything that we have learned so far before SQL, okay? So that is the introduction, the first 4 modules, right? So let me go back to the slides for today, and then if you have questions, I'll answer at the end of the session. So just some information about SQL, structured query language developed by IBM. And so as we mentioned, this is a query language, and it's different from like MySQL, SQLite, right? Or other tools that you use as a DBMS or database management systems, right? Those are the tools that you use to actually work, for example, with your tables, connect to your database, and provide just an interface for you to better handle your and work with your databases. And here is just a website that is very beginner friendly. I remember many years ago when I wanted to start learning almost everything, I used this website, especially because I always often struggle with the installation, everything, lack of space on my computer. So this is a good place where I don't recommend you to just stick to it. You have to still install SQL Server, but or use a cloud service. But this is just a good place to practice. And so we have different SQL commands, data definition language DDL, that I'm going to introduce today. And then we have data manipulation language, or DML, data control language, and transaction control language. We mostly focus on DDL and DML in this course. So we use DDL to create tables, to alter tables, or drop tables. That is getting rid of tables completely. And it's mostly about everything about the structure of the tables. That is what you have designed in your ER model. Now you want to convert it to actual tables in your database. So anything about the structure of the table, creating the tables itself, like the columns, the type of the columns, and so on. That is for altering the tables, or if you want to completely dropping the tables. That's different from deleting a table, and I'm going to explain later. And then later we'll have DML, or data manipulation language. That's once you already have the structure. Now you want to like do some, let's say, modification. You want to, for example, it can range from like select statements that you want to use, for example, to get your data, updating your the data in your tables, even deleting a table. But the difference that I'm also going to later explain is that DDL is mainly related to the structure of your table, whereas DML is mostly related to the data within your table. If, for example, you want to change the structure of the table, you use alter command, whereas if you want to, for example, change or update a data in your table, then you use an update command. So these are just different things. And I just explained set of commands to create and modify the structure of the database, right? This is why we mainly focus on tables. We still have like views, schemas, indexes, and everything. And when I'm talking about dropping a table, I mean get rid of everything, the whole structure, including primary keys, indexes, and whatever it has. And the goal is to just implement what we already had in our ER model. So this is the next stage also in your project, right? In your group project. After you finish your ER modeling and you created your relational schema and everything, then it's the time to actually use SQL queries to create your tables, create your database, create your tables in SQL Server, and then do some data manipulation, right? And what is a schema? The logical definition of a database. We'll see an example shortly. So here is just an example. So we have a relation schema and database schema. So relation or relation schema, relation in the context of relational databases is just a table, right? When I talk about the relation, I mean a table. Now, relation schema provide information about your schema of your table. For example, your database, for example, you have these tables, let's say product, orders, order line, customers, and then it defines, for example, what are the columns in each table, or for example, what is the data type of each column. Do we want to allow nulls or not? For example, which columns are primary keys, foreign keys, and so on. So these are what you define in your schema. We have different data types as well, numeric, character, string, and so on. So you can see like different data types that we have. For example, if a column, you're, for example, having a column like date of birth or anything that shows date, so the data type is not like integer, right? Then you want to define the data type as date. Or for example, if you have integer, then you define int. If you have float, you define float. And then char and varchar is used, they are used, for example, if you have textual, also textual and numerical information, or combined. For example, if you have a product number, I don't know, M1234, something like that. And the difference is you use char for a fixed number of characters. For example, let's say you have a product in your database, right? And you want to create a product table with product number. And let's say all the products have like 8 digits, and this is fixed. You know that all products have 8 digits. So when you define the data type, for example, car here, you can also identify how many characters it has. So it's a fixed number of characters. For example, car 8 means it has 8 characters in it, not more. And it allows us still like characters of 5, 4, or anything less than 8. And varchar or varchar is used when you have a variable number of characters. For example, you have a student name, right? A student name might be, for some people, is shorter, some people are longer, so you cannot say it's only 5 characters or 10 or what, right? But it's always good practice to define the number of characters, whether you're using car or varchar. I would recommend you like just for, because of optimally using your space, you can, for example, give it like, if it is a student name, then I give, okay, it's like 20, it may not goes more than 20 or 30 characters, or anything that you think that's the maximum number. And there are some data types that you will probably, at least for this course, use more. These are like the car and varchar that I mentioned. The n in the parenthesis shows the maximum number of characters allowed, right? If it is fixed, like product number, student number, and so on, you can use car. Still, you can use varchar as well, but it's more efficient to use car. If it is variable, like a student name, product name, and so on, or description, something like that, then you can use varchar. And then you can see also the maximum size. You have also text, which is variable with character strings, similar to varchar, as you see, but they have different maximum size. And we also have some numeric data types. The ones that I circled in red are the ones that you may need more. For example, integer, and you can see what is the range of the numbers allowed here. Numeric, we use it a lot. So numeric P and S in the parenthesis shows, for example, I'm going to provide an example to see, for example, how we define float, for example, numbers with numeric type. And then we have also the float. So these are the ones that I just added this slide so that you can see what are the ones that you probably use more. That those are car, varchar, integer, numeric, and this. So these x and y are the same as p and s, or a and b, or anything, right? And this is your number with x digits. Like for example, if you have 5 digits, and y of which are after the decimal point. So for example, if you have, I don't know, 29.58, we have only two digits after the decimal point, right? So y then is 2. And so how do we create tables? So we are not going to just read the slides and tell you how to create tables in this class. I'm just providing a preview first for you to know the structure, but then we'll have a hands-on once you install the SQL, we create tables together, okay? So very easy format, right? So you just write create table, that's the same, and then you provide the table name. For example, you want to create product table, so you write create table name, then just list all the columns below, right? And for each column, you have to provide the data type. For example, if this is a product code, followed by car, which is because product code is a fixed number of digits, right? For example, if our product code is only 4 digits, so we can define it car 4, right? And then if product code is your primary key, as you see here, you can SQL already assumed that it is not null. So it is not like, it's not incorrect if you write product code car and you avoid not null. But for all other columns that are not primary key, if you don't want to allow nulls in that column, you have to specify in front of that column when you're creating the table. For example, if you want to like for example the price column, right? If you don't want to allow any null values in the price column, you have to identify not null here when you're creating your tables. And unit price, numeric 8 and 2. So what does 8 refers to? You see here, X number with X digits, right? So that's the total number of characters you have. That includes the dot, okay? And then 2 is just means until 2 decimal points, right? You have only 2 numbers after 2 digits after the decimal point. So these columns, these tables, as you see, do not have any foreign keys, right? So creating tables is very easy. There are just a few things that you have to learn. First, the overall structure, which is easy, and later in your life you can always search for like these things. It's not the part that is important, right? The important part is knowing which table you have to create first. There is order in creating tables in your database, so that is one important thing, the order of creating tables, and adding foreign keys to actually link the tables. So these are the 2 most important things. Order in creating tables. So this is very important. For example, let's say back to our example, because in this slide I already provided example for order processing, right? So let's go with another example of a student registration now. So let's say I have the student. So this is your ER model, okay? So you have let's say you have a student. So, and you also have enrollment, and you have course, you also have instructor, right? Just a very simple one. I just want to show you something. And so we know that let's say this is my ER model, okay? So now I'm going to create the student table. So I just write create table student, right? And now here it comes all the attributes, like a student ID, name, like first name, last name, and so on, right? So here, when I'm creating this table, right, I have a student ID, right? What is the type? Let's say it's integer, okay? Or could be, for example, car, I don't know, 8, if it is 8 fixed values. And is a student ID your primary key? Yes. So you have 2 options to define your primary key. Either here, you define it here, you just write primary key here, or you can just keep this clean, listing all the columns here, student ID, first name, last name, and so on, and with the data type that they have. Let's say, for example, this is varchar, I don't know, 20, this is varchar 30, and so on. And then defining your primary key at the end. So this is another. Is SQL case sensitive? It is not, most of the time. So for what we use in this class, MySQL, SQL Server, that is not case sensitive. If you are using PostgreSQL, then PostgreSQL is case sensitive sometimes if, for example, you use something in the double quotes, okay? Just take care of like what you're actually using. For this class, it's not case sensitive. But it's good to always stick to one. Like for example, if you are defining, like writing lowercase, stick to that. Or if it's uppercase, the same. And then primary key, for example, is here a student ID, right? Do we have a foreign key here? No. A student table, does it have a foreign key? It doesn't. So you see why ER modeling is very important, because when later you want to write your SQL queries to create your tables, you have this ER model, and then you can easily write like a student table entity name comes as your table name, right? And then all these attributes will be your columns, right? And then you know what is your primary key because this was the unique identifier. You know what is the foreign key because you know the relationship, and you know that this is a one-to-many relationship. You know that foreign key is going to be added to the many side. So if I'm going to create the enrollment table now, so if this is an enrollment table and I have a student ID, right? I have course ID, and let's see, this is char at 5, right? And then I have grade, numeric, 5, 2, right? And so you have primary key, and you also have a foreign key. Okay. So here you can see how you can add your foreign keys. So for example, you write foreign key, that is your keyword, then the column that is actually a foreign key, in this case, in our example, a student registration, what is the foreign key? How many foreign keys do we have in enrollment table? 2, right? Again, that is why your ER modeling is very important, right? If you design it correctly, now you have no problem. But if you don't know anything about data modeling, and then you just come and say, okay, so we need a student table, I create a student table, I create course, and then after you enter the data, you'll see, oh, it's referential integrity, there are many errors, because you didn't know that you have to, that there is a many-to-many relationship, and you had to add another table as an intermediary table between them. That is why it is important, like the data modeling part is very important. While if you did it correctly, now you just write the code and it's very easy. The logic, I mean, you know the logic now. So you have your primary key, which is a composite primary key, right? You have both the student ID and course ID as your primary key. And here you can see how we define a composite primary key, right? For example, order number and product code in this example are your primary keys. So this is how you define composite primary key. How do you define foreign key? You just write your keyword foreign key and the column that is actually foreign key. Here we have 2 foreign keys, both the student ID and course ID, right? A student ID is foreign key because refer to the student table. Course ID is a foreign key because it refers to the course table, right? So, and here you write your foreign key. So primary key is, for example, a student ID and course ID. And then you also have a foreign key. The first one is a student ID, which references, right? Because you want to mention which table you want to link it. So far it only creates this table for you, like for example, this enrollment table for you. And it knows that, for example, a student ID and course ID, these are your primary keys. And so when it wants to link it to other tables, such as, for example, a student table, right? So it knows, right, that this foreign key, this is linking to this column, to this primary key, right? Whereas course ID is linking to, for example, course table. Is linking this table to the course table, and so on. So is this clear? So now back to the point I mentioned about order in creating tables, and why is that important? Why is it important to create, for example, some tables before some other? So I have a question. Can I create, if assuming I'm going to create tables for this ER model, okay? So for this ER model, let's see if it gets this. So we have a student, enrollment, course, instructor with these relationships. Which table do you think should be created first? Or tables. Which table or tables should be created first? A student and course, right? Why? Yes?
Because we need their primary keys for the relation.
They don't have foreign keys, in other words, right?
Yeah, for them.
Yeah.
Should we do instructor first before course?
Instructor before course. So let's see. Instructor and course have one-to-many relationship, right? Where the foreign key goes, many side, right? So we should add a foreign key when we want to define the course table, right? So when I'm writing, for example, when I'm creating the course table, right? Let's say we have course ID, which is car, let's say 4. And then we have course name, which is var car, I don't know, 10 or 20 or anything that you think is the maximum. Let's keep it 20 for course name. And description and so on. And then we also have, and let's say we define the primary key here. Primary key course ID. And we have a foreign key, right? And when we define foreign key, which is here, what is the foreign key in the course table? Instructor ID, right? Because it's connected to the instructor table. So it is instructor ID. References, instructor table. Now, what if you first create the course table? We cannot, right? Because course table contains a foreign key referencing instructor table. If we have not created instructor table yet, it means that our database doesn't recognize instructor yet. So you will get an error here. We'll show it next session in the hands-on session that if I write this and you see that what error you get. You get like a referential integrity error, okay? Because we are referencing a table that doesn't exist anymore. So we first have to create tables that do not contain any foreign keys, right? And then creating the ones with the foreign keys. Because the tables with the foreign keys are referencing some other tables. So we have to first create instructor. Now, if instructor has a relationship to a student, okay? And let's say each instructor can advise multiple students, but each student can have only one instructor, okay? If that is the case, can I still create instructor first? Yes, right? Still, the foreign key adds to the student part. So now, right now, if this doesn't exist in your database, which tables could be your first tables to create? Can I create a student first? Yes, there is no foreign key here. Can I create instructor first? Yes. So either student or instructor can be created first. But we have to make sure that when we want to create the course table, we should already created the instructor table. And when we create the enrollment table, which tables should we create before the enrollment? A student and course, right? Because it references both those tables. So if this is an enrollment, so we have course ID, a student ID, let's say this is int, and then we have primary key, course ID, a student ID, because this is a composite primary key and this is an enrollment table. And if you do not want to allow null in any of the columns, you know that you can just write not null here, right? I would like to let them have null because, for example, there might be student in my database that have not enrolled in any course yet and vice versa. And so foreign key, so forgive me for my handwriting. So foreign key course ID references what? Course table. Oh, one more thing. You have to be consistent with the names that you define, okay? And so what does that mean? It's okay if, for example, in the instructor table, you have, let's say, you write it instructor ID, okay? And then here in the course, you write, I don't know, ins ID or any other name. It's okay, okay? But you have to make sure that here you reference the correct name. So for example, if that's the case, when I'm, let's do it with the enrollment actually, because here I have a student ID and course ID, right? Now let's say in the course table, I define course ID as course code, okay? And this is my primary key here, okay? So I define the course code in the table to show the course ID or the unique identifier. Here I write it course ID, okay? If that's the case here, when you define the foreign keys, so you write, for example, foreign key CID, because this is how you define it in the enrollment, right? This is CID, references the course table. Which column in the course table? Course code, right? This way, it understands that this course code is the same as course ID. This can be useful, for example, several contexts. We have to see it actually with examples. And so here, one more thing. So in the order table in the example that you have in the slides, so first, back to this example. In the context of the example in your slide, you understand why we created the tables product and customer first, right? Because later we have, for example, order, which has a foreign key referencing the customer. So we have to make sure we create customer before order, right? And then order line should be created after both order and products. So which will be your first table then? So can I create customer first and then products? Yes, there is no problem in any of them. They don't have foreign keys. Now, can I create, for example, okay, can I create like this? Customer, I create customer first, and then I create this table order, which references customer, and then I create product. Why not? I'm not talking about order yet. So I'm going to create, So we have customer, product. So these are what we have. So if this example is clear, I'm going to clean it. Okay. So we have product, right? We have customer. We have order. And we have order item or order line. How is the relationship between them? Is there a relationship between customer and product?
No.
I like that. No, we don't have. Customer indirectly has relationship with product through order, right? Because customer place order, right? Forget about it for now. Customer place the order, and then order includes products, right? So this is the first thing we know. Do I need to connect customer to product? Not anymore, because we already have it, have order, right? So each customer can place multiple orders. How about order? Each order belongs to only one customer, right? Now, order and product. Each order can include multiple products, right? Each product can belong to many orders, can appear in many orders, right? So this is a many-to-many, and that is how we added order line, or here, order table here, right? So we need an associative entity here, such as order line, right? And then here, order line to product. So this way, we handle the many-to-many relationship. Now, let's go back to creating the tables, right? So I say, okay, I want to start from the product table. No, let's say start from the order table. So order is connected to customer and order line, right? And does it have any foreign keys? Yes, because it is in the many side to the customer, right? So it has customer ID as the foreign key, right? Because customer has one-to-many relationship between order, and we have to use foreign keys in the many side, which is in the order table, right? Because if we use customer ID as the foreign key in the order table, it means in order table, we have, for example, order ID, right? For example, order ID 1, and then this is customers. And each order belongs to only one customer, right?
But why don't we say a customer can place many orders at the same time?
Customer can place many orders, but each order belongs to a specific customer.
Okay, even if
Yeah.
the same person or the same customer place many orders.
For example, you go to Amazon and place an order. Can this order belong to another customer? No, that's your order. But you can go to, like, for example, Amazon, you can place many orders. You're the same customer, but placing many orders, right? So here, we said we add, so I would like you to really understand, right? Just don't memorize foreign keys added to the many side. I tell this, but my intention is that you know why is that. Because when you add it to the many side of the relationship, means adding course ID to the order table, it can handle it because each order can belong to only one customer. Whereas the opposite way, you cannot handle it because each customer can have multiple orders. Adding order ID here doesn't make sense. So I'm going to create the order table. Will I get an error?
Should we create the customer?
Yes, I will. Because this, if you want to create the order table, there is a foreign key referencing the customer table. Customer doesn't exist anymore. So let's create customer first. Can I create customer first?
Yes.
Yes. There is no foreign key in that. So let's say first I create the customer table. 2, I create order. Before product, is there any relationship between order and product? Between order and product.
What's the content of all the products? So order, product has to come first.
Product, okay. In terms of customer and order, right? We have to first create customer because order references customer. Yeah, do we have a product ID here?
So references product.
That is in the order item, order line table, right? Because there was a many-to-many relationship that we got rid of. So now there are one-to-many here, one-to-many here. So if you look at the table creation here, in the order table, we only have one foreign key, right? And that is customer. That means in order to be able to create the order table, you only have to create customer table before. Now it doesn't matter. You can create product first, customer second, order third. You can create customer first, product second, order third. You can create customer order third product. The thing is, product doesn't have any foreign key, right? So it doesn't reference anything. So it's not that you have to first create, for example, customer product, or it doesn't matter, right? Here, we needed to create order after customer. It doesn't depend to product at all. So this order is correct. This order is correct too. I can create product first, right? Doesn't have any foreign key. I can create customer, and third, I can create order, right? Both are correct. The only thing that matters is that we have to create order after customer. Now, how about the order line table? The order line table, think of it as an enrollment table, okay? Is to manage the many-to-many relationship between order and products, right? Now, each order line contains a specific product, right, for a specific order. Now, if I want to create order line, what are the foreign keys here? So first of all, there is a one-to-many relationship between order and order line, right? Each order can have multiple order lines, can appear in multiple order lines, but each order line belongs to only one specific order, okay? Now, order ID is a foreign key here, right? So this is one foreign key. It is also connected to the product table. So product ID is also a foreign key. So this foreign key connects the order line to the product. The order ID foreign key connects order line to the order. So which tables should be created before I can create order line? Order and product, both of them. So you cannot create the order line table if you have not created both of these tables before, okay? So now order line can come here. So you have to create both order and customer and then order line. Does it matter when we, like for order line, does it matter if it is created like after customer or not?
I think it does matter because you still need order which needs customer.
Exactly. So order line needs to be created after order. Order needs to be created after customer, right? So it's customer, order, order line. So that is why it's important. Otherwise, you get really like exhausted when you're creating tables with getting errors all the time because you have to know the order. And it's true also for when you want to insert data into your tables. Okay. So this is how do you create tables. I think we are okay for today. Do you have any questions? So I would just ask you to install SQL Server, follow the installation guide, and then we'll do hands-on next session.